Okay, let n be an integer. We're going to prove that these three statements are equivalent. 3n plus 2 is even, n plus 5 is odd, n squared is even. Ordinarily, when we have a proof of equivalence like this, it'd be nice to show that 1 implies 2, then 2 implies 3, then 3 implies 1, and just make a kind of a circle like that. Unfortunately, for this example, the only hypothesis here that's reasonably simple is actually the second one. Both 1 and 3 are kind of complicated. So the way that we're going to do this is we're going to show that 1 implies 2, 2 implies 1, then 2 implies 3, and 3 implies 2. So instead of doing a 1, 2, 3, instead of doing a circle, we're going to show 1 implies 2, then 2 implies 1, then got this wrong. Then 2 implies 3, and then 3 implies 2. So I still have everything implies everything else. It's just not in the form of a circle. Okay, so proof. 1 implies 2. We're going to do this one by contrapositive. Okay, assume that the negation of 2, so assume that n plus 5 is even. By definition, there is an integer k, so that n plus 5 is equal to 2k, which means that n is equal to 2k minus 5. Therefore, let's take a look at what 3n plus 2 is. 3n plus 2 is equal to 3 times 2k minus 5 plus 2, which equals 6k minus 15 plus 2, which is 6k minus 13. Let's write this as 6k minus 14 plus 1, and then I can factor 2 from the first two terms. Now, by the axioms of arithmetic, (3k minus 7) is an integer. K is an integer. Multiply by 3, still an integer. Subtract 7, still an integer. Therefore, 3n plus 2 is odd by definition of odd. So, therefore, if n plus 5 is even, which is the negation of 2, then 3n plus 2 is odd, which is the negation of 1. And so we've therefore shown that 1 implies 2. Next, we're going to show that 2 implies 1. So assume that n plus 5 is odd. By definition, there is an integer k, so that n plus 5 is equal to 2k plus 1. Or written another way, n is equal to 2k minus 4. Therefore, let's take a look at what 3n plus 2 is. 3n plus 2 is therefore going to be equal to 3 times 2k minus 4 plus 2, which is 6k minus 12 plus 2, or 6k minus 10. And so I can factor 2 out, 3k minus 5. Okay, so far so good. So now the thing inside of the parentheses is an integer. So by the axioms of arithmetic, push this forward. By the axioms of arithmetic, 3k minus 5 is an integer. Therefore, 3n plus 2 is even. And so that's the proof that 2 implies 1. Okay, next we move on to the proof that 2 implies 3. And just to remind ourselves, 2 means n plus 5 is odd, 3 is n squared is even. So assume that n squared plus 5, or n plus 5 is odd. By definition, there is an integer k so that n plus 5 equals 2k plus 1, or n is equal to 2k minus 4. Okay, let's see what happens when I square it. N squared is equal to 2k minus 4 squared. Now I could square this out, but instead let me factor this out. 2 squared times k minus 2 squared. 2k minus 4, that's 2 times k minus 2. So this is equal to 2 times 2k minus 2 squared, and I have successfully factored 2 out, period. By the axioms of arithmetic, two times k minus 2 squared is an integer. Therefore, n squared is even by definition of even. Now, if you decided to multiply this out and then factor a 2 out, there's nothing quote-unquote wrong with that. I just did something a little bit different here to emphasize that I'm pulling the 2 out by itself, and I really don't care how this multiplies out. Okay, lastly, we're going to do 3 implies 2. Okay, this one we're going to do by contrapositive. Just to remind ourselves, 3 implies 2 is to show that if n squared is even, then n plus 5 is odd. We're going to take the contrapositive. If n plus 5 is even, then n squared is odd. Assume that n plus 5 is even. By definition, there is an integer k, so that n plus 5 is equal to 2k plus 1, or n equals 2k minus 4. Okay, well, so let's see what happens if we square it. We have n squared. It's even, I apologize, I got mixed up. N plus 5 is even, so n plus 5 is equal to 2k. So 2k minus 5 here. I kind of got mixed up, I apologize. Therefore, n squared is equal to 2k minus 5 squared. Okay, let's multiply out. 4k squared minus 20k plus 25. That's the same thing as 4k squared minus 20k plus 24 plus 1. And on the first 3 terms, I can factor a 2 out. In fact, I can factor a 4 out, but that's not important. By the axioms of arithmetic, period. By the axioms of arithmetic, 2k squared minus 10k plus 12 is an integer. I'm not dividing or taking any square roots or anything, just adding, subtracting, and multiplying. Therefore, n squared is odd by definition of odd. So summarizing, hence, if n plus 5 is even, then n squared is odd, which is the contrapositive of what I was supposed to show, that if n squared is even, then n plus 5 is odd. So we've shown that 1 implies 2, 2 implies 1, 2 implies 3, 3 implies 2, and so their three statements are equivalent. And so that ends the proof.